Okay, here's a sample problem. We have figure 1 right here, figure 2, and figure 3. And we're going to have a look at what's going on there. So first of all, we're going to make a little table of values. Whenever we're trying to figure out a pattern, we make a thing called a table of values. We did it in the first example with cars and wheels. And now we're going to do it where F is the figure 1, 2, 3, and then B is the number of blocks. So in figure 1, we have 1, 2, 3 blocks. Figure 1 has 3 blocks. Figure 2 has 1, 2, 3, 4, 5. And figure 3 has 1, 2, 3, 4, 5, 6, 7. Figure 3 has 7. So now we have our table of values. Right here, that's our table of values. Now we want to come up with an equation. So let's see if we can come up with an equation for the number of blocks. So we want to say that the number of blocks is equal to something to do with the figure. So what is it? How do we get from 1 to 3? Well, we could add 2. Let's try that for figure 2. If we had figure 2, add 2, that would give us 4. So that's not going to work. If we go, how could we could go. So you're just going to have to play around to figure out how to get from figure 1 to figure 2, or the number of the figure to the number of the blocks. It's going to involve the regular mathematical functions, so try multiplication and addition, multiplication and subtraction, etc. So we tried figure 1 plus 2 gave us the number of blocks 3, but that didn't work when we had a figure 2 because 2 plus 2 is 4. But what if we multiplied by 2 and then added 1? So 1 times 2 is 2 plus 1 would give us 3. That works in the first case. 2 times 2 is 4 plus 1 is 5. That works. 3 times 2 is 6 plus 1 is 7. So we have a formula. It is 2 times the number of blocks. The number of blocks is equal to 2 times the figure number plus 1. And just try that out again. Does this generate this? 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. Yes, it works. Okay, so again we have blocks is equal to 2 times the figure plus 1. That's our linear equation. So we could go from that now, if we just flip over here, to creating a graph again. Okay, let's create a graph of that. So we have blocks is equal to 2 times the figure plus 1, or b is equal to 2f plus 1. Again, we're going to create, move back to our table of values, where we have, let's go with our figure and our blocks. When the figure is 1, we have 2 times 1 is 2 plus 1 is 3, 2 times 2 is 4 plus 1 is 5, and 3 is 7. And now we're just going to graph these. So I'm going to zoom in here. When the figure is 1, then the blocks is 3. When the figure is 2, then the blocks is 7. Oh, it's right off the chart already, right? Okay, let's try this again. So if the figure is 1, then the blocks is 5. 1, 2, 3, 4, 5. 3. 3. And if it's 2, then it's 2 to the 4 was 5. 2 is 5. So we got 2 and there, and then if it's 3, then it's 7. 1, 2, 3, 4, 5, 6, 7. And then we have this nice straight line again. In fact, if I draw that properly, it's going to look like that. So there we have our linear equation for b is equal to 2f plus 1. And we can use that to solve problems, because if you ask me if there was 10 figures, then I can plug that into my equation. If there's 10 figures, then I would go b is equal to 2f plus 1. But now f is 10, so that's 2 times 10 plus 1. That's 20 plus 1. The number of blocks would be 21. So that fits it all together.